Nobody has ever flown into the sun. Not because we haven't tried to get close, but because what the sun does to anything that approaches it is so extreme, so violent, so completely beyond anything we experience on Earth, that even our most advanced spacecraft begin dying long before they get anywhere near it. And the way they die is not what you expect. It isn't just heat. It isn't just fire. What the sun does to matter, to metal, to electronics, to the human body, happens in stages. Each stage more violent than the last, until there is simply nothing left. This isn't science fiction. This is what the physics actually shows. NASA launched the Parker Solar Probe in 2018 with one mission: get closer to the sun than anything we have ever sent before. It is the fastest human-made object in history. It has special heat shields. It cost $1.5 billion to build. And even Parker cannot go anywhere near the sun's surface. At its closest approach, Parker stays 6.1 million kilometers away. The sun's surface is still 6.1 million kilometers out of reach, because what happens between here and there would destroy it completely. Scientists know exactly what that destruction would look like, stage by stage, layer by layer, and it is deeply disturbing. Most people think the sun is close. It feels close. You can feel its heat on your skin from 150 million kilometers away. On a summer day, it feels like it's right above you. It isn't. The sun is 150 million kilometers from Earth. If you drove a car at highway speed, 100 kilometers per hour, without stopping, day and night, it would take you 171 years to reach it. Not months, not decades. 171 years of non-stop driving. And that's just the distance. The real problem starts long before you arrive. Think of it like walking toward a bonfire. 20 meters away, you feel warm. 10 meters, and it's uncomfortable. 5 meters, and it's painful. 1 meter, and you cannot survive. The sun works the same way, except instead of meters, we're talking millions of kilometers. And instead of uncomfortable warmth, the stages involve radiation that destroys DNA, magnetic fields that rip electronics apart, and temperatures that make the surface of the Earth look like a frozen wasteland. And this is just the beginning.
Long before heat becomes the problem, something else attacks: radiation. The sun constantly releases a stream of charged particles called the solar wind. On Earth, our magnetic field deflects almost all of it. We never feel it. We never think about it. But move away from Earth's protection, and the solar wind begins hitting your spacecraft and your body directly. At the distance of Mars, radiation exposure is already 3 times higher than on Earth. Halfway to the sun, it becomes 10 times higher. At 1 million kilometers from the sun's surface, radiation levels reach approximately 500 times what a human body can safely absorb in a year. In a single day at that distance, a human would receive a radiation dose equivalent to 500 chest X-rays every single day. The damage to DNA would be immediate. Cells would begin dying faster than the body could replace them. The immune system would collapse within weeks. The eyes would begin developing radiation cataracts. The brain, the most radiation-sensitive organ, would start losing function. Confusion first, then memory loss, then worse. Your spacecraft's electronics face a different kind of destruction. Charged particles punch through circuit boards like invisible bullets, flipping data bits and corrupting systems. The Parker Solar Probe has special radiation-hardened electronics. Even those require constant monitoring and repair cycles. But the radiation isn't even the most extreme force waiting closer in.
Here is something that makes no sense. The sun's surface, the part you can see, is approximately 5,500 degrees Celsius. That's already hot enough to vaporize every metal humans have ever worked with. Tungsten, the metal with the highest melting point we know of, melts at 3,422 degrees Celsius. The sun's surface is nearly twice that temperature. But the sun's outer atmosphere, called the corona, is 2 million degrees Celsius. The atmosphere is 300 times hotter than the surface beneath it. Nobody fully understands why. It should be the opposite. The further you move from a heat source, the cooler it gets. Move away from a campfire and you feel less heat. But move away from the sun's surface into its corona and the temperature doesn't drop. It explodes upward to 2 million degrees. Scientists call this the coronal heating problem. It remains one of the great unsolved mysteries of physics. One of the reasons Parker was launched was specifically to study this. Even after decades of research, the exact mechanism is still debated. What this means for a spacecraft approaching the sun is brutal. At 10 million kilometers from the surface, you enter the corona. At that point, you are not dealing with 5,500 degree heat, you are dealing with 2 million degree plasma. No material humans have ever created can survive that. The Parker probe's heat shield reaches 1370 degrees on its outer surface and is specifically designed to keep instruments at room temperature behind it. But that shield only works because Parker stays 6.1 million kilometers away from the surface. Push it closer and the shield itself vaporizes. And here is where it gets truly terrifying.
So let's say we build something, a theoretical probe. No heat shields, no special materials, just a spacecraft flying directly toward the sun at full speed. Here is what happens, kilometer by kilometer. At 40 million kilometers from the surface, solar panels begin overheating. Most spacecraft use solar panels for power. At this distance, they generate 10 times more electricity than they were designed to handle. The excess energy becomes heat. Circuits begin failing. Systems begin shutting down randomly. At 20 million kilometers, the spacecraft's outer skin reaches temperatures above 1,000 degrees Celsius. Aluminum, used in most spacecraft structures, melts at 660 degrees. The frame begins softening, warping, losing structural integrity. At 10 million kilometers, the spacecraft enters the corona. Plasma at 2 million degrees surrounds it completely. At this temperature, the difference between 1,000 degrees and 2 million degrees is irrelevant. Everything vaporizes simultaneously. Metal, electronics, fuel. Everything the spacecraft was made of ceases to exist as a solid object. It becomes a cloud of ionized gas particles, indistinguishable from the surrounding corona. Think of it like dropping an ice cube into the middle of a blast furnace. The ice doesn't slowly melt. It doesn't drip. It simply ceases to be ice in an instant. The spacecraft ceases to be a spacecraft the same way. It doesn't crash into the sun. It dissolves into it, long before reaching the surface.
Nobody will ever send a human to the sun. But the physics of what would happen is worth understanding, because it tells us something profound about how extreme our star actually is. A human body would not survive past the orbit of Venus, still 108 million kilometers from the sun's surface, without shielding. The radiation alone would be lethal within weeks. Approaching closer, the heat becomes the next killer. The human body begins dying when core temperature reaches 41 degrees Celsius. At 50 million kilometers from the sun, the temperature of unshielded space reaches levels where even a perfectly insulated spacesuit would eventually fail. The body inside would cook. At 10 million kilometers, still 10 million kilometers away from the surface, the human body would experience the same fate as the spacecraft. At 2 million degree plasma temperatures, the distinction between organic and inorganic matter disappears. Bone, tissue, water, all of it becomes plasma in microseconds. The sun doesn't burn you, it doesn't char you, it converts you, every atom of you, into the same superheated ionized gas that makes up the corona itself. You would become part of the sun, permanently, instantly, without any experience of it happening.
So here is the reality. The sun is 150 million kilometers away. It kills spacecraft with radiation millions of kilometers before they arrive. Its atmosphere is 300 times hotter than its surface, for reasons we still don't fully understand. And anything, metal, electronics, human bodies, that gets close enough dissolves into plasma before ever touching the surface. We have never touched our own star. We have never sent anything to its surface. The closest we have ever gotten is 6.1 million kilometers, and that probe cost $1.5 billion and is made of the most heat-resistant materials humanity has ever engineered. The sun is 4.6 billion years old. It will exist for another 5 billion years. And in all of that time, nothing from Earth will ever reach its surface. So here is my question. We can land on the moon. We are planning to land on Mars. We have sent probes to the edge of the solar system. But our own sun, the star that makes all life on Earth possible, remains completely, permanently untouchable. Does that bother you? Comment below, because it should.